Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, you're gonna look at a exam question under exponential function. So here we have a combination of an exponential function as well as a straight line function. So let's just dive into it. We are told that the graph of f of x it is given as negative b to the power of x plus 8 and g of x is equal to 3 divided by 2 plus 8. All right. Now, before we go anywhere, I want us to see here. Look at look at this equation. You agree the equation for an exponential function it is y it is equal to a multiplied by b to the power of x plus q, right? So we agree that the value of b it is here, whatever the value is, then q it is 8, then x it is x, right? Sorry. Now, what is the value of a? Since we have a negative here, now it tells us that the value of a it is negative 1, right? Yes. So it tells us that the value of a it is negative 1, which is less than 0. And remember, I said if the value of a is less than 0, it means I'll be having a graph that's more or less like that, of that shape. All right? Yes. Then we have a straight line 3 divided by 2, x plus 7. It has a positive gradient, right? We see 3 divided by 2, it is positive. So it means I'm expecting a straight line like this. Are drawn below. A and B are points of intersection. Remember, point of intersection, it is where f of x it is equal to what? G of x. It is where they intersect here, where these graphs are equal. A and B are points of intersection of f and g. B is the y-intercept of both graphs f and g. So we know B it is the y-intercept, and for y-intercept you know that your x value should be how much? Your x value should be 0. Then whatever the y value there. All right. So let me raise this. Let's look at the graph here. Remember, I said for exponential function I expected a shape like this, and this is what I'm having. All right, due to a being negative, then I have the value the straight line function as an increasing function here. Can you see that? Yes. All right. Let me remove this. All right. Actually, I want to only remove this. So now 7.1 says to us, write down the coordinates of B. Remember coordinates of B. What is B? B is the y-intercept of both graphs. But remember, if I'm having y it is equal to mx plus c, this is your y-intercept. The value of c is your y-intercept. So I go to my graph, my straight line graph, and check. This is mx plus c. Therefore, plus 7 it is my what? My c. Therefore, I know my c it is my what? My y-intercept. So I'm gonna say, therefore, my y-intercept here it is how much? It is 7. So here are the coordinates of B. The coordinates of B are 0 and 7. All right. If you do not notice that your C is your y-intercept, you can just substitute 0 here. Substitute 0 here. You'll see that 3 divided by 2 multiplied by 0, it is 0 plus 77. Or you can also substitute 0 here. On this x, it's going to give you negative. What is something divided by 0? It is 1 plus 8. Negative 1 plus 8, it is how much? It is 7. All right. So I believe you are following. Show that b it is equal to half. Which b? This b here. Show that b it is equal to half. So I'm gonna need any point that lies on f to substitute on this value of y as well as this value of x. All right, because at this point and moment I have three unknowns, but I can get y value from the graph as well as x value from the graph. Now I see that I have a as a point. I have a as a point on the graph, right? Sorry, if I have a as a point on the graph, then I can do my algebra there. All right, let's see. I'm gonna say, where is it? Oh, so I'm gonna say a sub this point negative 2 and 4 on f again, on f of x, right? So I'm gonna say, what is my y? My y it is 4 it is equal to what is my, or 4 it is equal to negative b. What is my x? My x, it is negative 2 plus 8. So I take this 8 to the other side, it is 4 minus 8, it is negative 4, it is equal to negative, I can say, 1 over b squared, negative 1 over b squared. Why am I saying 1 over b squared? Because remember, if I have a to the power of negative 1, it is the same as 1 divided by a. Or if I have a to the power of negative 3, it is the same as 1 divided by a to the power of 3. All right? So here is the same as saying 1 divided by b to the power of positive exponent. I believe you are following, because why? 1 divided by b, it is the same as b to the power of negative 1. So when I multiply this with these 2 outside, it's going to be b to the power of negative 2. All right? Yes. Then I divide both sides by negative. I have 4. It is equal to 1 divided by 2 squared. Right? Man, not 1 divided by 2. 1 divided by b squared, right? Then I can make 2 to the power of 2. 4 to an exponent of 2, which is 2 to the power of 2, which is 1 divided by b to the power of 2 here, right? If the exponents are the same, it means now this basis should be the same. Therefore, it means 2 should equal to what? 1 divided by b. But remember, since when I'm solving for b here, when I take the reciprocal on both sides, meaning if I'm having 4, it is equal to 1 divided by a. If I take the reciprocal of a, which is a, it means I have to take the reciprocal of 4, which is 1 divided by 4. All right, if I take this, remember, all right, let me show you like this. This is divided by 1. So if I take this at the top and this at the bottom, therefore it means I have to apply the same thing also on the left hand side. So it means I'm going to have a, it is equal to 1 divided by 4. So similarly here we have the same scenario here. We have the same scenario, therefore you can say therefore b, it is equal to 1 over 2. All right, this is a way of showing that. Or when you are here, you can say, let me see where. If you do not want to do this, you can say, all right, this is the same as, let me erase this. You can say this is, let me also bring back this b to the power of negative. What's happening here? Oh, b to the power of negative 2. All right. Therefore, I have just only divided by the negative part there. So what I'm going to do, this is b. This is b. So I'm going to take the negative root, like I'm going to say of 4, it is equal to negative 2 root, I don't know how to call that, of what? Of b to the power of negative 2. So we agree that this one and this one will cancel off, right? Therefore, we'll say, therefore, b will equal to, then you'll punch it. Sorry, this on your calculator, then you'll get what? You'll get half. So let's move on to 5.3, 7.3 rather. 7.3 7.3 says write down the average gradient between f and a, of average gradient of f between a and b. So the reason they are saying average it is because we are having a curved like this. So if we are having a curved thingy like that, the average that we are taking, it is between these two. So we agree that not all of this portion here will be covered by that straight line, right? So hence we are saying it is average because we do not know the exact, because we cannot take a what the gradient of that curved line unless you are in grade 12 where you have done calculus. All right, but in this case you haven't, so we call it an average gradient. So how to calculate average gradient? It is very straightforward. I'm going to say gradient of AB, it is what? Y of A minus y of B, y coordinate, right? Divide x of A minus x of B. Remember, if you started with y of B here, you have to start with x of B. So let me substitute y of a. Where is a? Here it is. 4 minus y of b, 7. Divide by x of a, negative 2, minus x of b, 0. Therefore, if I do my mathematical gymnastics, I get that 4, it is negative 3. Negative 3 divided by negative 2, it is positive 3 divided by positive 3 divided by 2. So, and it is a, this answer should be positive. Why? Because it is a straight line. So the gradient here should be positive. So the gradient between a b, it is 3 divided by 2. Let's just take a note of that. Say gradient of ab, it is equal to 3 divided by 2. All right, let's move on. 7.4. Write down the equation of the asymptote of f. What is our f? Our f, it is our let's just write its full equation here. Remember, the graph of f, it is our exponential function, right? So we have an asymptote here, the value of q. So the value of q, we know it is how much it is. It is positive 8, right? So that's our asymptote, very straightforward. Then the equation of our asymptote, you say y, it is equal to 8. You are done. Positive 8. You are done. This is your asymptote here. So it means this line, it is y, it is equal to 8, or you can just put 8 here, right? This is your asymptote. And remember, asymptote means asymptote, meaning what? Meaning that your this line of f, this graph of f will never touch that line. All right. So if they said what is the range of this, question, let's say they wanted the range. The range, remember, we start from where it starts, the graph. The graph starts where? At negative infinity. Right, remember, range, it is bottom to top. So our bottom, we start where? At negative infinity. You all agree with me? So I'm going to say y is an element of what? Negative infinity to where? It ends where? We know it ends at 8, because at 8 it will never touch, and we do not include that part. We say we use this bracket because it does not touch, meaning it is less than 8. All right. So you can say, or someone say y is less than 8, meaning the graph, it is somewhere where y is less than 8. Here at 7, it is there, our graph. At 4, we have our graph, as well as the others. All right. But this question was not there. It is just me preparing you for in case you have that kind of question in your question paper. This is 0 and 7. So let's move on to 7.5. Calculate the vertical distance between f and g at x is equal to negative 1. So now let's say somewhere here, this is negative 2, right? Somewhere here we have negative 1. So we want the what? The distance between the two. So now we have to check, or at negative 1, which graph is at the top. So we see, or at f is equal to negative 1, somewhere there. F is the graph that's at the top, right? F is the one that's at the top. Then now, let me do this section A. From this point to there, F, it is at the top, right? Whereas in that portion, G, it is at the G, it is at the bottom. So when we want the distance, we're gonna say, when we want the distance, it is y top minus y bottom. So meaning the graph that is at the top minus the graph that is at the bottom. In this case, we cannot use y top minus y bottom. Why? Because we do not know the exact uh, corresponding y values for both these graphs, right? So we're gonna say, all right, it's fine. The analogy will still be the same. The top graph is gonna be distance. Is gonna be, what is our top graph? Our top graph, it is f of x. Then our bottom graph, it is g of x. But now we are looking at this portion where f of negative 1 minus g of negative 1. We want the exact y value when x is equal to negative 1, or and g, the exact y value of g when x is equal to negative 1. When I continue with this calculation, I'm going to say, therefore, I'm going to substitute negative 1 on my x. I'm going to substitute x as -1 on my f graph, right? My f graph, it is negative what? 1 divided by 2 to the power of -1 plus 8 minus, this minus is from the formula. What is g of -1? Is going to be 3 divided by 2 multiplied by -1 plus 7. Let me do this instead. Let me use this bracket. Therefore, the answer that we get there, just punch your calculator there. Just punch your calculator, you'll get whatever value that you get, and your answer should be positive. Why? Because now it is your what? It is your distance. Remember, if you're doing physics, you know that distance, it is always positive, but changing x, which is our displacement, it is negative. So let me try to do this. This is -2 plus 8. This is 6. 6 minus all right, our answer, it is half here. Our answer, it is half. What? Half units. All right, half units, or 0.5 units. Do not forget to include units. All right, let's move on to another question. So we know our distance here. Half units. All right, so we can move on to another question. It says now, describe the transformation of f to h if h of x, it is this one. So now let's see, from f of x to h of x, what happened there? What was f of x? Remember, f of x was negative half x plus 8. Then now it has transformed to what? To positive half x minus 5. Before we go anywhere, can you see that these signs in front as well as this sign, they have changed, right? One might, all right, so the question is, how can those signs change now? The only time that those signs might change, it is when we multiply. It is if I multiply this left hand side graph with my -1, right? But now there should be a reason why I multiplied this graph with -1. Let me do this. Let me show you. If I say this is f of x, it is equal to -1, negative half x plus 8. How can I just multiply this part by -1? Only that can only happen if my f of x was negative, like this. If my f of x was negative, oh sorry, was negative like this, when I divide by negative on all of this part, I'm going to have f of x is equal to positive half x minus 8. So you now see my signs are the same, positive, positive there, negative, negative there. But now, how can we get a f of x to be negative? The only time that you can get f of x negative, remember, f of x is the same as y, right? So remember, if I'm having a coordinate x and y, how can I make, and check something, my x did not change here, it was positive, and here is still positive. So remember, if I want to change this, what kind of transformation is this? If I change my y to be negative but my x is still positive, remember, this is the reflection across the what? This is a reflection across the x-axis. Why am I saying this is the reflection across the x-axis? X-axis. Why am I saying this is the reflection across the x-axis? Because now the value of x did not change, it remained the same. But what happened to the value of y? It changed. Remember, I said if I'm having a coordinate here as -2 and 4, if I reflect this point across the x-axis like this, nope, like this across the x-axis, check what happens. The value of x remains the same as -2, but what happens to the value of y? It changed to negative 4, because here the y values are negative. So the first thing that they did here was reflection across the x-axis. Reflection across the x-axis. Why? Because now our x value did not change, but our y value in particular changed from negative positive to what? To positive negative. But that's not all. If this, after, let me do this. Let me do this. After reflection across, this is what we expect. We expect a f of x to be positive. What? 1 divided by 2 to the power of x minus 8. This is what we expect a f to be after a reflection across the x-axis, right? But now check something. More or less, this thing is the same as this, right? But now the difference comes here. This is -5, this is -8. So how did our graph move from -8 to -5? So we're gonna determine another transformation or translation or reflection. So what happened? So it is the same. H of x is the same because here it is 1 divided by 2x. But now it is -5. So how did we move from -8 to -5? So if this is -8, -7, -6, -5. How many units did we move? We move 1, 2, 3. So how many units? 3 units where? To the right. All right. So it means therefore, if it shifted up and down or left to right, we say therefore, yes, shifted 3 units where? To the right. Let me write this. 3 units to the right. Then after 3 units to the right, remember you add just 3. Not to the right. Remember this is your Q. And remember Q it is your horizontal asymptote, so it either moves up or downwards. So it is shifted 3 units to upwards, actually 3 units upwards. 3 units upwards, not left. But if it was a change here, maybe a change here, plus P. So you're gonna say P units to the left or right. All right? Yes. So since well it is Q, it is upwards. So the answer here, the perfect answer, if you answer this question, it's gonna be a, where is it? It's gonna be first one, reflected. All right. Reflection across the x-axis and shifted 3 units upwards. This is the perfect answer for 2 marks. For 2 marks, reflection across the x-axis and shifted 3 units up. Right? Yes. So I believe you are following. Then let's tackle the last question. For which values of f of x is greater than or equal to g of x? Now this question here, it is not that difficult. I'll try to show you how we tackle this question. All right. Now, what I'm going to ask you to do, we know the coordinate here, it is 0 and 7. Remember, when you answer, your answer will be in terms of x. For which values of x is f of x greater or equal to 0? So this, if I take this statement and write it in simple terms, it is where f of x is above or equal to g of x. Greater than means it is above. It is find the values of x where f of x is above or equal to g of x. Let's start first by finding where they are equal. The x values. The x values that they are equal at, it is what? The first one is here, x it is equal to 2, -2, and the second one it is x it is equal to 0. Critical point. Critical point that we have, it is they are equal at -2 and 0. These are our critical points. They are equal there. negative 2 and 0. So what I'm going to ask you to do is do this. Come here and say, all right, I'm going to do this. Let me show you like this. This is negative 2 where they are equal, right? And this is x is equal to 0 where they are also equal, right? So we agree that this portion here, negative 2 and 0, it is this portion, right? Where they are between negative 2 and 0, right? And from 0 to infinity here, this is infinity, this is negative infinity. It is from here to there. And from negative 2 to negative infinity, it is from here to there. So we want where f of x is above g of x. So let's say this block here, the top one it is f of x, the bottom one it is g of x. Let's start from negative infinity to 2, from this portion to this portion. Let's see which one is above and which one is below. All right. So from this portion to this portion, we all agree that g of x, the straight line, it is above g of x, f of x. We agree. Yes. From this portion to that portion, this is above this. So we're gonna say, all right, from this portion, f it is what graph is this? The straight line graph. Let me see. G it is above. Agree. So we're gonna say, all right, the above one it is what? G. G it is above, and now F it is below. All right. Then we come from this for this section, negative 2 and 0. Negative 2 and 0, it is this portion. So in that portion, which graph is above, which one is below? We see who this graph, this one. Which graph is that? The graph of the exponential, it is above, and the graph of exponential, it is graph of f. So it is above. So therefore, this one, it is below. All right. Then let's look at this portion from 0 to infinity. Which graph is above? This graph of g. We all agree. The graph of g, it is above. The graph of f, it is below. So this is the graph of g, it is above. Then the graph of f, it is below. But Rona, what do we want? We want where f of x is above. F of x is above. All right. So remember, if f of x is above, automatically g of x it is below. So we want where f of x is above. Which portion is that? So we can see that from this portion, negative 2 to 0, f of x it is above. Below, above what? Above g. So it means we want this portion where f of x it is above. So it is between negative 2 and what? And 0. But now they said above or equal. Or equal. Equal where at negative 2 it is equal. At 0 they are equal. Our graphs are equal. We all agree that at negative 2 they are equal, and as well as b they are equal. You can see here. All right. So we're gonna include this. So this is our solution. This is our solution for this part. But someone might opt and saying the answer, the x is between what? Negative 2 and what? And 0. But now, since it is equal, we're going to use this. If it did not have equal, we would have used this instead. All right? Yes. So thank you very much, folks, for watching our YouTube video today. I hope you enjoyed the video. If you did, please give it a thumbs up and kindly subscribe to our channel. Thank you.